be seeing me as well. I hope. Wonderful. Okay, so welcome back to our GIT class. Some of you were away yesterday, I heard. Those of you who were away, are you present today? I also hope you've had time to review the material we went through. You went through quite a lot of material, some of it quite abstract. But by now, you should have some idea how branches are implemented in GIT and how the merging operation works. Today, we're going to continue looking at GIT from the point of view of being a graph manipulation tool. As we said several times throughout this course, GIT is just a graph manipulation tool that supports version control methodologies. Today that will become even more apparent, I think, because today's lecture is all about how we manipulate history in GIT. That means how you actually move commits around the commit graph. So let me see if I can bring up the slides. And again, all the slides are available online. Umuzi, GitLab.io, Git slides. You probably all have that URL committed to memory by now. And let's move on to today's slides. Merging was yesterday's topic. Rewriting history, that is today's topic. But before we do so, we're going to have a look at commits again from a different point of view. So far, we looked at the internal structure of a commit. We looked at how a commit consists of mainly a tree, which is generated from the index, which again points to several blobs inside the object store. So in a sense, so far we've looked at commits as being a very static, unchanging bundle of files. But of course, a commit also has a different interpretation. If you look at a commit which has a single parent, you can think of the commit as representing the change set that is needed to go from the previous commit to the next commit. Because between those two commits, something has changed in the code base. Maybe on line 57, you added a new statement, or you deleted line 92. Maybe you modified a line. Maybe you appended to a line. But whatever changes you made to the text, you made some discrete changes, and those can actually be found. Because remember, Git internally usually compares objects. It'll look at two commits and it'll see how do you get from point A to point B. So the second point of view you should have with respect to commits is that they can be thought of as change sets. And there is a command in Git which will allow you to see what kind of change set a commit represents. And that is git show. So let's see how that works. Let's bring up the terminal. And hopefully you can see the terminal on your screens now. Is the font size big enough? Is it legible? Can you see what it says? I'm going to just create a new repository. Git test 2, I guess. This is just going to be a very simple one-off repository. Create a folder, initialize a repository, and then just write a simple statement to a text file. Just make it simple. I'm going to do it this simple. See, Umuzi.txt. Okay. And then we're going to add the file to the index and commit. Okay, as we all know, we now have a very simple commit graph with a single commit on it. We're now going to make some changes to that file. Let's add a line to it. Below the first line, just add anything, any statement, any sentence whatsoever. And again, we're going to add the file to the index and we're going to commit. And hopefully you're still following me. At this point, we've created 2 commits, which we can see from the graph. That's the first commit, followed by the second commit, where we appended a line. Now, I want you to think of the second commit as a change set. I want you to think of it not as a bundle of files, but representing that we added a line, we appended a line. And to get this point of view from Git, you can use Git show, and then you'll need the commit hash. And now I need to see if I can find my mouse pointer. Whoop. There we go. And you can see that Git, well, let me just remove the clutter from the screen. Git show and then the commit hash. And you'll see the way Git now represents the commit is through first printing the metadata, the author, the date, and the commit message. And then you're getting a diff. And that diff tells you something about how the files inside the repository were changed under that commit. So as you can see, it made a change with Umuzi.txt in the first commit on the left side and Umuzi.txt in the other commit on the right side. Or better yet, you can see it's made a change where this file still retains its old name, and the change that was made was we added a line indicated by this plus here, as well as the somewhat different color of that line in the terminal. Is everyone at this point now where you have been able to bring up the diff set in your terminal? You can see the diffs, the diff of the file that you just modified. Or did I go too fast? So again, this diff set basically says we modified the file Umuzi.txt by appending a line. How are you in this case? The other lines that are printed are just there for context. They're just for you to be able to say exactly where in the file you are. Where the change happened is also indicated in the diff set by this cryptic line here, saying something about which lines were modified. It's not important at this point in time to know exactly how to read the full diff set. It's just important that you can see a diff set represents the changes that were made to the file. And now if we modify the file again by, say, removing the first line, saving, staging the file, and committing. Removed first line. By the way, you can see that I wrote my commit message in the imperative mood. I wrote remove instead of removed. And that is somewhat of a convention in the Git world. At least the original developers of Git suggest that whenever you write a commit message, you should, first of all, find a good verb that describes the action you did. Did you add something, remove something, fix something, modify something? And that verb should go in the imperative. Remove, not removed. Fix, not fixed. And that goes hand in hand with looking at a commit as a change set. Basically, a commit is a change that you can apply to your code. And applying this code, applying this commit, applying this change set will remove the first line. So instead of seeing a commit as a point in history, you can think of it as a command, something that is done to your code by applying the commit. Now, if we look at the graph by running git log graph, we have 3 commits. And we'll now run git show on the last one. And it'll tell you that you deleted a line, which is what we did. So, just tell me when you're at this point where you've made these modifications and you've been able to verify that git show gives you a diff set that makes sense. And again, the command is git show and the hash. Now, as we've mentioned earlier, a shortcut for the currently checked out commit, or if we're going to be absolutely accurate here, it's actually a pointer to the branch of which the currently checked out commit is the head. A shortcut or alias for that is the @ sign. So what you can do if you want to run a diff on the currently checked out commit is git show @ and it'll show you the same thing. Remember, @ is basically a pointer to the currently checked out branch. The currently checked out branch points to the currently checked out commit. So there's 2 levels of indirection here. How are we doing? We all on the same page? There's very little happening in the chat right now. So if someone could say something so I can see that you're still with me, that'd be good. Has everyone been able to do this? Or did we go too fast? You're good? Okay, great. Well, moving on. Let's go back to the slides. And Sid is pointing out that you can see from the diff set that it says -sign hello Umuzi. Right, and it should also show that in red, indicating that line has been deleted. So I want you to carry with you this notion that a commit is not just a bundle of files. It can be thought of as a change set, as something that was done to the previous commit in order to get to the next commit. Moving on. Now we're going to talk about how we actually modify history. And here, a word of warning is definitely in order. Because what we're going to do now is going to change the commit graph. It's going to remove some commits and recreate them other places in the Git graph. or it's going to modify branches so that the history changes. In other words, the set of commits that is on that branch is going to change from what it was before. And if you make a change to a branch, or if you rewrite history in a public repository, in a repository where other people commit their code or get their code from, that can create issues for other people. And if you want to change history in a repository that's used by other people than you should have a very good reason to do so. Sometimes there are very good reasons to do so, and we might touch upon some of those a bit later. But the rule of thumb is don't rewrite public history. However, rewriting your own local history, as in rewriting commits that you're the only person who's ever touched and who's ever seen, and that you haven't published to the public yet, that's perfectly fine. So with that in mind, let's talk about how we change commits. And the first thing we're going to look at is what's called interactive rebasing. That's what you do to a commit that you're not happy about, or maybe a range of commits that you're not happy about. Let's say you went through a series of changes and you created a series of commits, and then you realize, oops, my commit messages were wrong. Or, I've committed a lot of commits, I've created a lot of commits, and some of these are meaningless, maybe some of them are just a few touch-ups to the code, and I don't really need to commit those, I don't really need to publish those for the world to see. Or maybe you did something stupid, maybe you staged a file you shouldn't have staged, and suddenly you now have a huge file or a file containing personal information inside your repository that you don't want to be there. What do you do? Well, in that case, fear not. There's interactive rebasing that'll help you to deal with situations as those we've just mentioned. And the syntax is pretty easy. It's git rebase, and remember this is interactive rebasing. There's going to be another form of rebasing which we'll look at later, but whenever you're going to run an interactive rebase, you're going to have to remember to use the -i flag. Git rebase -i. The next parameter is going to be the commit that you're working from. So you're going to have a range of commits in history. And the from commit tells you how far back throughout the history of the repository you want to go. And then you're going to be presented with a list of all the commits that happened since then. And as we'll see, it'll allow you to make changes to those commits. And now Sydney's asking, by saying don't rewrite public history, do you mean you should only be working on your own branches first and then merge to master when you're done? And yes, part of what I'm saying here is exactly that. Usually when a lot of you are working on the same code base, you should never publish things directly to the master branch. You should usually create your own feature branches or your own topic branches for the work that you're doing. And that's where you should keep your code until you're ready to integrate it with everyone else's code. And on these feature branches that you have a lot of leeway with doing whatever you want, rewriting commits, so on, because usually those branches only reside in your local computer until you're done, at which point you merge all those commits that you created into the master branch, which is a public branch. And after you've done that, when you've merged your code into the public branch, into the master branch, that history is now public, as in you've put your code and you put your commits on a branch that everyone else uses. And at that point, you should not change anything. But when you're working on your own topic branches, when you're working on your own feature branches, feel free to make changes as long as those as long as you're the only one working on those feature branches, and very often you are. And yeah, the follow-up question is, are you talking about open source repositories that are freely available to the public? No. By public in this case, I mean your team. When I say public history, I mean the history that the other people on your team will see, not just you personally. So usually there's going to be at least 2 of you. I mean, unless you're working on a very small personal project, you're going to have a team of at least 2 people. And as long as one other person on your team is going to check out a given commit, that can be considered public history. So public here is with reference to the rest of your team, not the public in general, the wider community of people. Did that make sense? Okay. Well, now let's have a look at actually rewriting history. We're going to bring up the terminal again. And we're going to continue working on this repository. Let's open the file again, Umuzi.txt. Now, let's say we add a line. How are you? I'm not being very creative today. Okay. And now what we're going to do, we're going to stage the change we made. And we're going to commit it, but we wrote something really stupid in the commit message. Right now, I'm just going to write something that doesn't make any sense whatsoever. Something went wrong. We had an aneurysm. Something happened. Our commit message doesn't make any sense. It's just a string of nonsense characters. That's usually not what happens. Often what happens is that you write the commit message that didn't really describe your commit properly. And whenever you write the commit message, it should make sense to the rest of the team. Sometimes you just describe the changes you made in a way that doesn't make sense. Or maybe you just violated internal conventions about what the commit message should look like. Anyway, what we've done now, we've created a commit message that we need to change. And what we're going to do is we're going to have to figure out what commit hash we need to modify. And to do that, bring up git log. And here on top is the commit that we want to change. Now in Git, what you need to do is to figure out the commit that comes immediately before the commit you want to modify. For some reason, Git will allow you to modify everything from the commit hash you provide, not including that very commit. And I'm not entirely sure why that is the convention. But the point here is that this is the commit we want to this is the commit we want to modify. This is the commit that comes immediately before it in the list, in a linear list, when we just do git log without showing the graph. So what you're going to do is to copy that hash, run git rebase -i, and then the hash. If you do that, you should be thrown into a text editor. And I'm not sure what text editor you've set as a default. Very often it's Nano. And I think most of you have encountered a terminal text editor by now. I hope so. What you can see here is that you're getting a list of every single commit that you've selected. In this case, we've selected only a single commit. And it'll show you a keyword. It says pick right now. Then it'll show you the first few characters of the hash, and then the beginning of the commit message. Now, if you look further down, you can see that there's a range of commands here. Pick reword, edit, squash, fixup, exec, etc. And these are the commands that you can run on the commits that you select in order to modify them. In this case, what we're doing is we're rewriting history. We're selecting which commits to retain, and we're selecting which commits we want to actually modify. And when you save this file, Git will go through the list and it'll do exactly what you ask Git to do. If it says pick, that means that you're going to retain the commit. Nothing will happen to it. As long as it says pick to the left of the commit will stay as it is. However, what we're going to do now is to remove pick and write reword. Now, you don't actually have to write the full command. As you can see, you can choose, it allows you to just use a single letter to indicate the command that you want to run. So instead of reword, we can actually just type R. And that is usually easier. So I'm just going to leave it like this, with an R indicating that we're rewording this commit. So, is everyone at this point now where you have a window in your terminal, you're inside a text editor, you have a list of commits, and it tells you whether, it asks you what you want to do to those commits. Is everyone there? Does anyone have a problem with getting to that point? Yes, you are. And if something has happened and anyone needs some more time, then please tell me. We'll make sure to make provisions, make sure that everyone gets to where they need to be. But it seems like most of you are now where I'm at. And hopefully you've now placed an R next to the commit you want to reword. Now save this text file. Save this file. And Git will bring up another window. It'll now ask you to actually modify that commit message. And at this point, rewrite the commit message and write something that makes sense. Hopefully, you should then see, after you've saved the file and quit the text editor, that Git successfully rebased and updated refs. Now, if we scroll up, see here, this is the previous commit history. We had 4 commits. The initial commit, then we appended to the file, then we removed the first line from the file, and then we had this commit, which did something meaningful to the file, but the commit message didn't make any sense. The commit hash was 5374 in my case. In your case, it's going to be something different. Let's now run git log again. Johan is saying you can't save the file. Okay. What kind of error message are you getting? And when you say the file, are you talking about the list of commits where you chose what to do to the commits? Or are you talking about the commit message? Now, while you're looking into that issue, the rest of you can now note that the commit that didn't make any sense has been replaced. And we have a new commit in its place with a different hash. The commit message is now changed to what we set it to be. And of course, if we look at the graph, it is what we expect it to be. Now, of course, what we've done is to completely rewrite history. The branch now looks different from what it did before we did the rebase. So this is why we call it changing history or rewriting history. Johan is still saying the list of commits, you're not able to save that. Okay. What text editor are you using? Are you using Nano? Are you using Vim? Are you using Emacs? Are you using something else? Nano. Okay. Let's try and see if we can do this editing in Nano by setting editor equals Nano. I'm going to export that. Let me see if I have Nano installed. Yes, I do. Good. Oops. I'm not used to Nano. Quit, save, no. Okay, I'm going to run the Rebase again. Git Rebase I. Okay, now I just want to show you something interesting here. Git has a nice range of shortcuts and aliases that you can use. Remember how I told you that the @ sign represents the latest commit that you've checked out, as long as you have a checked out branch. Now what you can do is you can use the relative symbol, this tilde, to say how many commits back from where you're at you want to go. And remember, we want the latest commit. I think this should work. Tilde 1 should go 1 commit back in history. Let's see if that worked. And it did. We're getting 1 commit. However, Git did not bring up Nano for some reason. So let me just not make any changes. Git config editor, is that what it is? Equals Nano. No, it's not. Okay, so I'm sadly not able to bring up Nano for you. It'll have to be Vim on my part, so we can't go through the issue here. But try and see if you can reproduce this later if you're not able to do this in Nano. And those of you who actually were able to do this, maybe you can try and figure this out together with Johan. But for now, I think we have to move on. We only have about 15, well, we have 5 minutes left of today's class. So what I want to do is to introduce it to a few more of the commands that you can run when you do an interactive rebase, and that's what we'll have time for today. Let's bring up the rebase. No, what we're going to do is we're going to make another change to the repository. We're going to add a commit. We're going to be stupid. Let's say that for some reason you added a file you shouldn't have added, like something like this. Definitely not something you would like to check into your repository. Right? I just added a file with some credit card details. By the way, Sydney's saying that in order to fix the problem, you can try and run editor equals Vim. That'll set Vim as your editor. You can try that. Try and change your editor to Vim and see if that helps, if Nano is posing a problem. But right, now we have a file here that we don't want anyone to see. Now let's say we make a change to Umuzi.txt. And for some reason you changed in every single file in this directory. Very easy to do. You might have done git add asterisk or glob, which will just take every single file in your working directory and add it. So let's do that. If we do git status, it it'll tell you that we've now actually staged the credit card details.txt as well as Umuzi.txt. Imagine we didn't notice that and we committed this. Git commit change Umuzi.txt. Now, git commit. Right, now there's a file in that commit where we don't want to be there. What do? We run an interactive rebase. Git rebase -i. We're going to use the @ sign. We're going to go back one commit. Enter. And now what we're going to do is not to reword the commit, we're going to edit the commit. Editing it will stop right before the commit is created, and it'll allow you to change the index. Because remember, a commit is created from the index, and if you make changes to the index, that will change what goes into the commit. Be it files or blobs, directories. And then you'll also actually be allowed to change the commit message, I think. So let's do that. Select edit, save the file. And what it's saying now is stopped at, and then the commit it stopped at. You can amend the commit now with git commit amend. Once you're satisfied with your changes, run git rebase continue. What we're going to do now is we're going to remove the credit card details from the index. And to remove a file from the index, you can use git rm. So we're going to run git rm credit card details. That's also going to delete the file from the working directory. Now it's removed. If we run git status, it'll tell you that among the changes to be committed right now, as in among the changes on the index, is that we've deleted credit card details.txt. And once we're happy, once we're done, once we've changed everything we need to change, we run git rebase continue. And now you're also allowed to change the commit message, but we're going to keep it the way it was. Now you should see that Git has successfully rebased and updated the branch. If you do ls, the file is gone. If you check out that commit again, at any point in the future, that file will be gone. We edited the commit. And you can edit commits as far back in history as you want. So if you at some point realize that a few days back, 20 commits back, I did something I shouldn't have done, git commit rebase will allow you to go back, make changes, and rebase everything. So I think that's all we have time for today. Next time we're going to look at non-interactive rebasing, which is a slightly different thing altogether, but very important when it comes to a lot of Git workflows. And we're going to talk a little bit about some different work philosophies surrounding Git, mainly merge-based workflows and rebase-based workflows, which are two different ways of using Git for the same purpose. But okay, hopefully most of you have been able to go through the practical exercises today. You should have been given some new Git exercises yesterday, I think, covering commits and covering branches. Have you been given those exercises? Or were they not given to you? They have received exercise 3. Very good. Okay, I'll see all of you again tomorrow then. And it worked. Johan is now back. Like, wonderful. That's excellent. Thank you very much for following this class today, and I'll see all of you again tomorrow. Have a good day, and see you then.